Hi guys, welcome to my channel. In the last lecture, we designed a 4:1 multiplexer using 2:1 multiplexer, and the 2:1 multiplexer was further designed using Tristate buffer. So we'll proceed with how we can synthesize the circuit in Verilog. So I've already created three files, which is Tristate module, MUX2, 2:1 MUX module, and 4:1 MUX module. All three are empty files only. However, we'll first start with the Tristate module. It will have an input 4 bit, so 320A. It will have an input enable, an output Y, which is also a 4 bit. I'll use the blocking assignment here for assigning Y. When enable is on, it should assign output A. Otherwise, output should be a floating value which is indicated by 4TBZ. Okay, we'll save this file. Okay, done saving. Now we'll proceed with designing of 2:1 multiplexer. Again, this will have input, which is a 4 bit, 320, and input shall be A1, A0, and it will have a select line input S, and output Y, which is again a 4 bit. Y. Now we'll use the Tristate module here for designing 2:1 multiplexer. In the diagram shown, the 2:1 multiplexer can be designed using two Tristate buffers. Okay, so Tristate buffer will be designed like Tristate. I'm using the same Tristate name followed by module instantiation. Let's say like A0 has having Tristate buffer name T0 with arguments A0. Okay, and A0 should be on when S is select line is 0, so I'll give a NOT gate here, and output should be Y. Similarly, A1, I'll copy this, Tristate, write A1 there. This let this be Tristate T1, and this input will be A1. E1 should be passed when select line is 1, so I'll not pass a NOT gate here. Instead, it should be select line S, and output is connected to wire Y. Okay, now we have designed a 2:1 multiplexer using two Tristate buffers. We'll save this file. Okay, automatically the hierarchy is changed on the left hand side, as you can see. Now we'll design a 4:1 multiplexer using 2:1 multiplexer. As indicated, input will be 4 bit, which is 320, A3, A2, A1, and A0. Select line will be of 2 bit for 4:1 multiplexer, so 1:0, yes, and output shall be again Y, which is again of 4 bit. Okay. Now, as we designed in the last lecture, I had given a wire for the first multiplexer M1 out and M2 out for the second multiplexer. I'll declare those wires here. Wire which are also 4 bit, so wire 320, M1 out, and next wire will be of M2 out. Okay, now we'll proceed with design of 2:1 multiplexer. We'll give the module name MUX2, and let this be M1. Okay, arguments will be A3, A2, and select line is of lower bit S0, so S of 0 I'll pass here. Okay, and then output should be a fire M1 out. So it is this. I'll copy this for the second multiplexer also, which is lower multiplexer. Mux 2, it should go to M2. Input will be again what A1, A0. Select bit line remains same, which is the lower order bit line, and output should be M2 out. The last multiplexer, let me name it M3, which connects wire M1 out and M2 out. So A1, A0 should be what? It should be M1 out. A0 should be M2 out. And select line should be of higher bit now. And output should be assigned to Y. Done. Okay. Now let's save this. You can see already hierarchy has been created. 4:1 multiplexer is having 3 2:1 multiplexer. Okay, and one multiplexer will be having two tri-state buffers, T0 and T1. So this is how we can synthesize structural modeling in Verilog. We'll proceed with checking syntax if any error is present. Okay. Yeah. So checking syntax here. Okay, no errors and warnings. We can proceed with designing the RTL schematic. Double click on this. Okay, RTL schematic is designed now. As indicated in the diagram of 4:1 multiplexer, it will have 4 inputs, A0, A1, A2 and A3. All inputs are of 4-bit, 2-bit select line, 1 to 0, and output is of 4-bit Y. You can double click to expand the modularity. Okay, and okay, something seems to be wrong here because there should be 3 multiplexers. Let us check in the code if anything is wrong. This input is 20, output is 4-bit, okay. And 183 that's not. Okay, so this is also proper. We'll check for mux 2 now if anything is wrong. Input 320A1. Okay, Tristate. Okay, it's proper. Save this. Okay, everything is proper now. Input, enable input is given. Let's check on synthesizing. If any IC error is present, rerun this. Yeah, so now it was designed properly. Yeah. So you see, like the 4 is to 1 multiplexer is having 4 inputs, which is A0, A1, A2, and A3. There are 3 multiplexers inside a 4 is to 1 multiplexer. One with a higher multiplexer at the top and lower multiplexer below. This is having inputs A0, A1. Second multiplexer is also having input A2 and A1, which are further connected to the same line. Okay, and those final wires M1 out. This is M1 out wire, and M2 out wire is connected to the final multiplexer M3, and output is a 4-bit bus Y3. Okay, so I hope this is clear, and as suggested, if you face any issue, you need to like check in the module hierarchy design. I had made one error in this tri-state buffer where I didn't declare output y as 4-bit, which is why in the end the diagram got changed. So you should make sure that you can like debug this into a deeper hierarchy level so that you don't you can avoid errors further. Okay then, this is for this video, and let me know if you have any doubts in the comment section. Thank you.